Good morning, students. In this session, we are going to see about topic on diesel cycle from the subject ME 8792 Power Plant Engineering from the unit 2 Diesel and Gas Turbine and Combined Cycle Power Plants. Diesel cycle was invented by Rudolf Diesel in 1893. He put forward an idea by which can attain higher thermal efficiency with a high compression ratio. All diesel engines works on this cycle. Cycle is used as a fuel in this cycle as it can be compressed at higher compression ratio. It is also known as constant pressure cycle because heat is added in it at constant pressure. It has high thermal efficiency and compression ratio as compared to Otto cycle. It is a diesel cycle diagram. It consists of 4 stroke: intake, compression, power and exhaust stroke. It has a 4 process. First one is isentropic, that is reversible adiabatic process. Second is a constant pressure, that is heat addition process. Next one is isentropic process, that is expansion process, and constant volume, that is a heat rejection process. The process one is a suction stroke. This is when the piston has to move downwards, creating a vacuum that sucks air into a combustion chamber. And process 2 is a compression stroke. Once the piston reaches that lowest point, it removes up again and compresses the air in a combustion chamber to very high pressure. The pressure is so high that it heats up the air to beyond the temperature at which diesel ignites. Process 3 is a power stroke. The power stroke starts with bang as at the end of the compression cycle, the fuel is injected into a combustion chamber via the fuel injector. The fuel ignites as it mixes with a high temperature air inside the chamber. This controlled explosion forces the piston back down, producing work. Process 4, it is an exhaust stroke. Finally, this is when the piston moves back up and pushes by products of combustion out of combustion chamber. This is called the exhaust stroke. After this stroke, the piston repeats the process 1 and follows the same cycle again. The figure shows that PV and TS diagram of the cycle respectively. In this process, 1 to 2 is a adiabatic compression, 2 to 3 is a addition of heat at constant pressure, 3 to 4 is a adiabatic expansion, and the 4 to 1 is a rejection of heat at constant volume. The point 1 represents the cylinder is full of air. Let P1, V1 and T1 be the corresponding pressure, volume and temperature. The piston then combines the air adiabatically, that is equal to PV power gamma is equal to constant. Then value becomes a P2, V2, T2 respectively at the point 2. The heat is then added from the hot body at a constant pressure. During this addition of heat, let volume increase from V2 to V3 and temperature to T2 to T3 corresponding to the point 3. This point 3 is called point of cutoff. The air then expands adiabatically to the condition P4, V4, T4 respectively corresponding to the point 4. Finally, the air rejects the heat to the cold body at constant volume till the point 1 where it returns to the original state. It is a piston position of diesel cycle. Here, the eta diesel is equal to 1 minus 1 by R power gamma minus 1, where eta is equal to thermal efficiency, alpha is a cutoff ratio, V3 by V2, R is a compression ratio, gamma is a ratio of specific heat, that is equal to Cp by Cv. The cutoff ratio can be expressed in terms of temperature as shown below. T2 by T1 is equal to V1 by V2 power gamma minus 1 is equal to R per compression ratio power gamma minus 1. T2 is equal to T1 into R into gamma minus 1. V3 by V2 is equal to T3 by T2. Alpha is equal to T3 by T1 into 1 by R power gamma minus 1. Thank you.